Hello, everybody. Yeah, you got a little bit of a pseudo day off today. I'm gonna be spending the day at Gatorland in Orlando with my niece because I managed to convince my sister to give her the day off school. That's actually kind of good or kind of fine because we were a little bit ahead of the game, and the only thing that was left for me to explain was the Z table. So I'm going to leave you a couple problems, and they're going to, I think, three problems. The first one involves computing z-score, which you learned yesterday. Well, it will be 2 days ago by the time you probably see the video. But now we're going to learn how to actually functionally use it using the z-table. So I'm going to give you an example, and I've got this right here, and so this is totally a made-up example. I don't know if these numbers are probably not correct. But let's say that I surveyed all of the faculty at CNU who are runners, and I asked them how many miles per week they run. The average of the sample was 34 miles per week. The standard deviation was 5.7 miles. I personally run 40 miles per week. What percentage of CNU faculty runs less than me? And the flip side of that, what percentage of CNU faculty runs more than me? So we can answer both questions with the table, and I'll show you how. It's really simple. But first thing you need to do is compute the z-score. So in this case, the z-score is my case 40 minus the average of 34, and then divided by the standard deviation of 5.7. That ends up giving us a z-score of 1.05. So once you have that z-score, let's go ahead and bold that. This is where you break out the table. So this is the z-score table that you see in Scholar. So there's actually two different sides of this. And so there is a negative side and a positive side. Now, the positive side is for positive z-score numbers, for cases that are above the mean, that get positive z-score numbers. The negative side is for negative z-score numbers, for cases that are below the mean that end up with negative z-score numbers. So to use either side, the basic process is exactly the same. And one thing I want to go ahead and point out is table values represent the area to the left of the z-score, which to the left of, if you remember thinking of a distribution, what is to the left is the area that is less than, that is smaller than. So all of these numbers on here, they represent the area to the left of a given z-score. And they're decimals, but they also can be converted right into percentages. If you were to take the decimal point on any of these and move them over to places, you get a percentage. And that is the percentage of the sample that is less than your given case. So I have a z-score for my 40 hours a week that's 1.05. So let's find the table value that's associated with my z-score of 1.05. So to do that, you take the first two digits. In my case, it's 1.0, and you find it on this column right here. So it is the case that 1.0 is right here. So 1.0. And then you take your third digit and you find it on one of these columns. So I got 1.0 is my first two digits. My third digit is 5. So 1.005. So here's the 05. So this is going to be this row in this column. So ultimately, this is my table value. So this tells me the proportion of people in the sample that run less than I do per week. So not to toot my own horn, but I do run about 40 miles a week. And if the average CNU faculty member were to run 34 miles per week with a standard deviation of 5.7, it would be the case that 85.31% of the sample runs less than me. And so let's go ahead and find out what the opposite of that is. So you can take that same information, you can find out what percentage run more than you. I can already tell you it's going to be almost 15%. But in order to find that, I mean, you can just do 85.31 or your table value, and then you subtract that from 100. So 14.69% run more than I do. Because you know how many run less than you, and so in order to find out what percentage runs more than you, or it has a higher z-score on literally anything, all you have to do is take that number that is on the left side of the sample, and you subtract it from 100, and that's the percentage that's on the right side of that case in the distribution sample, or sample distribution. So yeah, that's basically how to use the z-score table. Oh, I seem to have lost it. There it is. So just remember that, to find your table value, you take the first two digits of your z-score, and then you find the last digit, and it's right here, and then find where they converge. And just remember, whether you're using the negative side of the table or the positive side of the table, the value that you get always represents the area to the left of the z-score. In other words, the value that you get always represents the proportion or percentage of the sample that has a score that's lower than the given score that you are looking at. So I am going to give you a few problems. I think 3 problems to work on. I'll make them do... Probably I'll make them do before we have class again. So I'll make them do Sunday night. So we'll say that Friday is an asynchronous day. But the actual thing that's due, I'll make that due Sunday night. So you don't necessarily have to do it tomorrow. But you're basically doing what I did just here. And so that's not terribly complicated. Anyways, I will see y'all again on Monday. I'm actually looking forward to getting back to class. I weirdly miss campus, miss my students. So, yeah, I'll see y'all on Monday, back in the class, and enjoy your weekend. Enjoy your Friday. Bye, everybody.